As usual, let's get started with some pre-class questions. Here are 4 pre-class questions. Go ahead and do them and then enter your answer on Edpuzzle. All right, now that we're back, let's go ahead and start with section 3.1, solve linear systems by graphing. The essential question, how do you solve a system of linear equations graphically? And our objective is to solve systems of linear equations. So our key concept, what is a system of linear equations? Well, today we're going to talk about a system of linear equations in 2 variables, x and y. We also call it just a linear system. And it consists of equations that could be written in the form of ax plus by equals c and dx plus ey equals f. Now what I like to do, and you're going to see me do this throughout the notes here, is I like to start to number these equations. So that would be top equation, equation number 1, and the bottom equation, equation number 2. And that just keeps my work organized. So we say a solution to this system will be an ordered pair. So notice it's going to be an x comma y that satisfies or makes true both of these equations. So when I substitute in both the x value and the y value into both equations, I get a true value. Now what's interesting is when I graph both of those equations, I get 2 lines, and that solution will actually be the intersection of both of those lines. And that's why I'm going to make it very important that we write our answers as that ordered pair x comma y. All right, let's try example number 1. So we're going to graph the linear system and estimate the solution. So we have 2 equations. We have equation number 1 and we have equation number 2, and I'm going to use a different color. Okay. So looking at equation number 1, we have 5x minus 2y equals negative 10. Now looking at this equation, it looks like if I use the intercept method, it might make my life a little bit easier. So finding the intercepts, first I'm going to let x be 0. That means I solve and I get y is going to be 5. Now for the other intercept, I'm going to let y be 0. When I substitute that in and use the cover-up method, I get x is negative 2. I'm going to do the same process here for the second equation. So equation number 2, we have 2x minus 4y equals 12. Again, let's try the intercept method. So if I let x equal 0 and I solve for y, I get negative 3. And then when I let y be 0 and I solve for x, I get 6. Okay, now let's go ahead and graph both of those points. So for the first point, I go 0, 5. And I go to negative 2, 0. And I happen to know another point, so I'm just going to go ahead and graph that just to help me do a straight line. And then we have 0, negative 3 for the, let me just go ahead and connect these dots. Here is that line. And then let's graph the other one. 0, negative 3, and 6, 0. And again, I know another intersection. And then if I try to connect those as best as I can. And if you notice, I see an intersection. Now, the better you do this, the better you graph, the better it is to find the intersection point. And if you notice, the intersection is negative 4, comma, negative 5. Now, to check your answer, all you have to do is substitute that into both equations. So we're going to take 5 times negative 4 minus 2 times negative 5, and hopefully that equals negative 10. And we also substitute that into the second equation. So 2 times negative 4 minus 4 times negative 5. And that should equal 12. And when you do the math, it does. So that is the solution. All right, so why don't you guys try guided practice, problems 1, 2, and 3, and enter your answer on Edpuzzle. All right, moving on to our next key concept. So we have some definitions here. So we say a system is consistent if it has at least one solution. So at least one solution, we say the system is consistent. If a system has no solution, then the system is inconsistent. If a consistent system has exactly one solution, it's independent, whereas if it has infinitely many solutions, it is dependent. Okay? So what we've been working on in example 1 was an example of a system that is both consistent and independent. All right, let's try example number 2. So solve the system, then classify the system as either being consistent and dependent, or inconsistent. All right, so we have the system 6x minus 2y equals 8 and 3x minus y equals 4. Okay, so the first thing I'm going to do, the intercept method doesn't look like it's going to work as nicely. So here, let's take a look at the first equation, 6x minus 2y equals 8. And let's go ahead and solve for y. So subtract 6x from both sides. So you have negative 2y equals negative 6x plus 8. And then you divide everything by negative 2. So then you have y equals positive 3x minus 4. All right, let's try the next equation. 3x minus y equals 4. Subtract 3x from both sides. So you have negative y equals negative 3x plus 4. Divide everything by negative. And you have y equals positive 3x minus 4. All right, going to graph this. So we have negative 4 on my y-intercept. And 1, 2, 3 over 1. 1, 2, 3 over 1. And it looks like that's the first equation and that's the second equation. You get the exact same line out for both. So they would be graphed right on top of one another, which means every single point would be a solution to both systems. So what we write is, we say the graphs are the same line. Okay, so the system is consistent and dependent. Okay, and let's move on to example number 3. So now we're going to solve the system and classify it as consistent and independent, consistent and dependent, or inconsistent. So again, let's take a look at both equations. So here's the first one. We have negative 4x plus y equals 5. If I add 4x to both sides, I get y equals 4x plus 5. In the next equation, I have negative 4x plus y equals negative 2. And if I add 4x to both sides, I get this. So I have y equals 4x minus 2. All right, let's try graphing the first equation with blue. So we go to plus 5. My slope is 4, so 1, 2, 3, 4 over 1. And then 1, 2, 3, 4 over 1. And it's going to look something like this. And let's try red for the second equation. So minus 2 and then 4 slope. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And it's going to look something like this. And if you notice, you get parallel lines. Okay? So we say the graphs are two parallel lines. Okay? The system is inconsistent. And let's move on to example 4. So here's an example of a word problem. So a soccer league offers two options for membership plans. Option A includes an initial fee of $40 and costs $5 for each game played. Option B costs $10 for each game played. After how many games will the total cost of the two options be the same? So organizing my information, it looks like I have two options. Okay, so we have option A and we have option B. Okay, and it looks like we're talking about games. Okay, so that's going to be my only variable. So let's define that. Games are X. For option A, $40 plus $5 for each game. So how about this? 5X plus 40. Whereas in option B is $10 per game. And we want to find out when they're the same. So when do these two things equal? So solving, subtract 5x from both sides. So we have 40 equals 5x divided by 5, and we get x equals 8, which means 8 games we have equal options. All right, moving on to guided practice. So again, go ahead, try these on your own, 4, 5, and 6, and enter your answers on Edpuzzle. Excellent. So that was it for this lesson. Tomorrow during class, you will be working on this in small groups. The homework is on pages 156 through 158, numbers 6 through 11, 20 through 25, 28 through 31, 35, and 36. And if you have any questions, feel free to use the discussion forum I'm going to post on Haiku, and I will be checking on that throughout the week. Thank you.